Good morning, welcome back to Sparkipedia. It's been quite a while. I've now successfully started the Masters course, which is broken down into quite a few modules, as I'll post on Sparkipedia at some point. One of the more interesting modules so far is the group project, Meng project, Masters project. This one involves us actually making a racing car, which is quite cool. Have done one of those before. The group is split between mechanical engineers, motorsport engineers, and myself and one other electronic engineer. And it's actually for a proper event. There's a competition involved. And basically we're designing a composite monocoque vehicle for the Green Power Electric Racing Series. And this is a phase 2 project, which means that somebody has already started the project in the previous year. And we have a shell, a carbon fibre composite racing shell, which I'll get some photos of at some point to stick on here as well. Yeah, so basically me and the other person are in charge of the electronic side of the project. And there are lots of rules and regulations. For example, the motor is done. We're going to be given one, we can't play with it. That's in the rules. And also we have certain batteries, and we can't play with those either. So, we are limited in certain respects. So the aim basically is to be able to go as fast as we can for as long as we can, and beat the competition. However, the system will still need some interfaces. Bear in mind this is an electric motor, not a petrol motor. And up until now, as you've seen, I've been using PICs and various forms of PICs and some Altera boards, but I'm yet to use the Raspberry Pi. And I thought it was about time. So I had this thing since last year, and I've never really used it. So there she is. It's the Raspberry Pi, just over there. So yeah, I spent yesterday for the first time playing around with it. Took me a little while to get used to it, but it's pretty good. I haven't used Linux a lot, I have to admit. I know I used some of the Altera stuff last year, but I've actually tried to avoid it as much as I could, if I'm honest. Yeah, so currently I've got a class 10 SD card in there, so a nice fast one, 16 gig, and I preloaded it with Raspbian Wheezy, which is that's a very common operating system for the Raspberry Pi. That's all installed and working quite happily. It's got quite a nice GUI actually. If I just tilt the camera, if I just tilt the camera up a little bit at the screen, I'll come back a little bit. There we go. So this is all running from the Raspberry Pi itself. There's a nice user interface. You can do your word processing. You can check your emails. You can go online. You can do quite a good mixture of things, to be honest. So it is, as they say, a computer. It's pretty cool. Yeah. So first things first, I got that working, and I thought I'd try and set up GitHub, because although I didn't use GitHub last year, my team members did, and they are right. When you're working on code for a project, when you've got a number of other people doing it, Dropbox is fantastic for documents and general work, but it would be terrible with lots of people playing with code all the time, because although it has got version control, it's not the best, and the logging and data is just not helpful. So anyway, I set up an online resource, a repository, under the Sparkipedia. And everything's going on there, so I'll put a link to that. It's an open source, so anyone can have a play with it if they want to and take the code, and feel free, it's fine. Yeah, so I basically had a go at using the GPIO pins in the beginning. That's where I am now. I wanted to do it in C. I know lots of people do this, and there's loads of languages you can use. I mean, you can use Python, you can use C, you can use Visual Basic, you can use I don't know, the C++, I guess, there's quite a few different ones you can choose from. But I wanted to go for C, as I said. And so first things first, I had to find a library that would support all the GPIO pins and everything else on there. And there seemed to be, after a little bit of research, two sort of main contenders. But I went for the BCM2835C library. And that's based, I think that's actually based on the library that's inside the hardware itself anyway, so that's pretty good. So yeah, I installed that, and then I had a go, and as you can see, there's the result there. Got some Knight Rider LEDs going back and forward. But yeah, I'm quite impressed with the Raspberry Pi. I like it. You might recognise that little board from last year's project if you watch my videos. Something I found quite interesting, although saying that it might not work, no my luck. I've run this code obviously, so night red LEDs going up and down, but you can have more than one instance of the same code. I did this by accident really, of the same code running. So if I run it again, and then if I exit the program that I'm coding it with, and if I open it up again, bear with me. The Raspberry Pi is great, but it can be a little slow. Yeah, I'm just loading it up. 1 second. Compile that again. Yeah, so as long as you exit out of the program, I'm using a program called Genie, or however it's pronounced. I run it again. Look at that. So you can have more than one instance of the code running. So now, if I do it a third time, bear with me for 1 second. Just take a little while to close and open. Just do it one last time. There we go. See, it's pretty cool. So yeah, so I plan to have a lot of fun with this. The product itself, basically we're thinking of using some graphics-based LCD screens. These actually came in the post the other day. They cost me a whole £15 from eBay, which is a hell of a lot cheaper than buying them online. There you go. On top of that, I also bought some 3-axis gyro sensors, which are hiding over here. 1 second. These are great little bits of kit. Basically, I wanted to. The car wants to be able to monitor the acceleration and the angle, so we can work out its position. And these little boards, you can probably see them just inside there. They run via SPI, which again we are familiar with if you watch my videos from last year, albeit with the PIC. So the basic plan here is to have this racing car with a little LCD screen control, and then there's going to be the sensors themselves there. There's also going to be a couple of temperature sensors around the airflow of the car itself, so around the engine, and I'm not quite sure where the second one's going to be mounted, but it's going to be mounted somewhere. The idea, we can see how obviously the air flows and hitting the temperature of the engine and everything else. And sorry, I'm just trying to find something on my laptop here. Give me 1 second. Where did I put this thing? There we go. Yeah, so basically we're also thinking about using engine braking to make the most of our batteries. So underneath the foot pedal for the brake, there's going to be some sort of micro sensor probably with a spring, and so it gives a bit of weight. Every time you press the brake, that will trigger and will reverse the DC motor, and use engine braking to spin it, and so generating electricity and charging the battery. That's possibly one way we've thought about prolonging the life of our battery so we can get a bit further and go a bit faster. We're also thinking of using drag sensors to work out what forces are acting on the car as we go around the corners. We probably won't, but we thought it could be a laugh putting a little GPS sensor on there and making a little on the LCD screen itself, making a little thing like a co-pilot, saying in 20 yards is a right turn and 30 yards is a hairpin, that kind of thing. This is also going to control a horn, because we have to have a horn as per regulations. And maybe a speed sensor as well, I'm not sure yet. But yeah, it's still work in development, but I think it's going to be a pretty good project, so I'll keep you updated. Thank you for watching, and this is Sparkypedia signing out. Bye bye.